All right, welcome back. This is the Virtual Residency 2025 workshop. This is our 11th annual workshop, and it is Wednesday, June 25th, 2025. This is our fourth and final session of the day. So I want to welcome you all, and our topic is research data management, and Chris Simmons will be our moderator, and I'm going to turn the show over to Chris to introduce the panel.
Thank you very much, Henry. We're here today, as Henry said, to talk about research data management and sort of share our experiences. I'm Dr. Christopher S. Simmons, just call me Chris. I'm scientist in residence at Cambridge Computer, a company that some of you guys might do business with, but I was in academia for 30 years, from faculty member to running research computing groups to running data centers. I still contribute to academia and open source, where I help run the Open HPC project. And more salient for today, I help run the Open Storage Network, which is the S3 as a service for the Access program. Next up, we have Brad.
Hi, I'm Brad Spitzbart. I'm a facilitator with the Faculty of Arts and Sciences at Harvard University. We support everything from the School of Public Health, Science and Engineering, Business School, Law School, and Humanities. Somebody just posted the other day, we have now over 100 petabytes of storage capacity at security levels 1, 2, and 3. So we have a secure data enclave. While my day-to-day job is as a facilitator is mostly helping people set up accounts and all of those access issues, setting up storage, helping people run jobs, and all of the oddball things that users come up with. But fortunately, about a year and a half ago, we gained a dedicated research data manager. So we work closely with her, and there's a lot of overlap to get communication out to labs. So I'm glad to be here. Hopefully I'll offer a facilitator perspective and a lab perspective.
Thank you very much, Brad. And Sean?
Hey everybody, I'm Sean Cleveland. I am the Director of Research Cyber Infrastructure for the University of Hawaii 10 campus system. I've been involved within research cyber infrastructure for at least 16 years in doing research software engineering, data management, various aspects of things, as well as PI on a couple of awards for CC Star computing as well as storage. So I've done a lot of things working with researchers on building systems for doing data management, as well as working with them in engagements of how they're going to manage their data for many, many years between Montana State and University of Hawaii. So thank you.
Fantastic. And Kristen?
Hi, I'm Krista McLean. I'm the manager of Research Data Management Services at Northwestern University. I've been in my role for almost 2 years. It was a brand new role that was created out of just the growth and need for data management services across our campus. I've been at the university about 15 years, but really am not a PhD. And I have had a very unconventional journey to this role, working a lot with data in my life, from financial data, human resources data, but also doing a lot of business analysis and project management, and also as a security lead over at one of the schools for the engineering school, and then found my way back to central IT. I currently have a team of 4 folks working for me, which is amazing. We have a lead data management specialist, 2 data management specialists, and then a virtualization and cloud computing specialist as well.
Fantastic. Thanks, Kristen. And Brock?
Hi, I'm Brock Palin. I'm the Director for Advanced Research Computing at the University of Michigan. We're the institution-wide research computing provider covering HPC, research data, secure enclave, and other services, including data science consulting. We currently have a team of about 23 people, but that's a little misleading because we have a very decentralized support structure. So we provide services centrally, but a lot of larger units provide their own support. And that's actually where most of the data management expertise actually lies across all the different disciplines of our academic medical center, physical sciences, life sciences, social science, and humanities. We currently have over 100 top 10 graduate programs and about $2 billion a year in research activity. So it's quite broad and diverse across all those different disciplines and things like that.
Fantastic. And Sasmita?
Hello, everyone. I'm Dr. Sasmita Mahapatra. but you can call me Shashmita. I am a research scientist and HPC facilitator at the University of Texas at Dallas, located at Richardson, Texas. And my role is very much like a facilitator, like although like managing the data of the researchers, students, and the faculties. And yeah, through orientations and facilitations, we try to educate our researchers how to do the data management and data backup, and all those things. Thanks.
Fantastic. Thank you, everyone. So I'm going to actually combine the first two questions together, and we're going to kind of ping pong back and forth. So the first question is, what do you consider the top 3 components or aspects of research data management? And the second question is, what experience and observations have led you to the list of this component? So I'm going to start off with one, and then we're going to kind of go around until we feel like we've covered the topic. And I'm going to take the easy one, FAIR data, right? So we've heard about FAIR for a while. It's a proven component, and it's something we need to do. For those of you not familiar with the acronym, FAIR is findable, accessible, interoperable, and reusable. So findable, do I know where the data is? Can I find it? If I'm looking for a data set, do I have the means to locate it? Accessible, is it presented in such a way that I can consume it? Interoperable, is it deployed and available in such a way that you can work with many different tools and have ways of going from one workflow to another? And reusable, can it be used for other science and repackaged for other applications? And why do I think FAIR is important? Well, for me, it comes from an equitability aspect and a reproducibility aspect. So, not everyone can collect data, and sometimes the people who are collecting the data are the haves, the people who don't have the data are the have-nots. And I'm a real big fan of FAIR just to lower the barrier of entry and increase the reach of data sets and how other people can work with it. And if you've ever listened to any of my talks over the last decade, I've been coming to, Henry's events from, I don't know, since 2017, 2018, something like that. I'm a big fan of reproducible science. And science, by definition, is supposed to be reproducible, but 99+% of papers published that involve computation probably aren't reproducible. And when you start bringing in data, then the problem becomes, even larger. But if I'm pitching FAIR, we live in a capitalist society and money sort of shines. And just some interesting data points around FAIR. The European Commission estimates that the lack of fair data practices cost the European economy almost $10 billion annually. And they estimate that's going to increase to around $26 billion over the next couple of years as AI/ML comes into production. Another interesting data point is that the Human Genome Project invested $3.8 billion into making that available. And the research on it has shown an economic impact of almost $800 billion with over 300,000 jobs created. So FAIR is important for equitability, for reproducible science, and because everyone likes money. So, Brad, you're up. Oh, you're on mute, Brad.
All right, we got Zoom cooperating. My number one is, again, from a facilitator perspective, documentation and training. So we try to put as much documentation online for our users as possible. Everything pages from general principles, how to create a data management plan and a storage plan, data policies and procedures. Then we have fairly clear pages with all of our storage options and the features of each one and how to use them, workflows to lay out lab organization and data transfers as well, and the whole data lifecycle to help labs build their workflows. So we conduct quarterly or at least semi-annually specific trainings on research data management so that we can cover those topics as well as to make sure that users know where to find that documentation and references so they can help themselves. And then that's exactly why this is important, a little bit selfishly, so that we don't have to answer tickets about it. But when we do get those tickets, we do have the documentation. Send them a link, or know that we need to create a page because people are asking about that and need help with it.
All right, fantastic. And Sean?
Let's see. For me, I think my top two, three are in here would be kind of like, is the data stored, safely? Are we helping researchers recognize that they need about two or three copies, ideally, of their data so that they're not in danger of losing it? Have that they don't have it stored on a jump drive on their keychain and they lose their keys and their data's gone or their laptop crashes and all the data is disappeared. So having a few copies and geographic distribution and as Brad mentioned, is it easy for them to be able to do this and leverage some of the infrastructure that we have in place for researchers to do this, like using Globus or SFTP or different cloud technologies and things like that? Have we covered that? Then security would be the next aspect I would think would be important. Is the data stored on the appropriate systems for it? Is there PHI, PII, those sorts of things that we need to consider so that the researchers are in compliance with institutional data governance as well as funding requirements. And then my third one would be getting to the metadata is like, do we have the data about the data and the provenance of the data so that the researchers can work through analysis and sharing and collaborating later. So those are kind of my top three when I'm looking at data research data management initially, if we're going to limit it to three.
Yeah, fantastic. And a little more around, data classification. It's now, if you haven't started already, now is the time to start thinking about governance frameworks and data classification management, right? The granting agencies have been threatening for almost a decade to bring 800-171 as requirements for all, data, CUI, right? Controlled unclassified information. And if you're building it from scratch and you've never written a system security plan, expect to spend over a year and a couple of FTEs to build that infrastructure. By the time you need it, if you haven't started, you're a year behind, right? So start thinking about it sooner rather than later. Kristen.
So a couple of mine were touched on as far as life cycle, but I wanted to kind of get back to data classification and protections and understanding, coming to a consensus with the faculty member about what kind of data they have. I think a lot of the times they don't know or they don't want to know because they just assume that all of their data is public. It's like a level one. It does not matter. I don't need protections. Nobody cares about it. But the fact of the matter is, we do care about it. You received an award. We are getting paid for you to either generate and or protect this data. So we do need to understand what it is and what you're doing with it and what ultimately, how it will be published, how it will be used. So trying to find that happy medium between what the researcher understands their data to be, what my interpretation would be, but then also going back to our Information Security Office or the IRB and the Institutional Review Board and figuring out what they think it needs to be, and then trying to come to another consensus about where that data should be stored. So obviously faculty members are going to want to put their data in the least, like the most frictionless data storage solution possible so that they can do whatever they want with it when they want and collaborate with whoever they want and share it. But that's not always going to be the case. So we do need to point them to our data storage solutions that are aligned with the right data classification and the right data protections and really inform them and train them about how to use it and how to appropriately work within the confines of the technical controls that we have in place versus the best practices that we want them to use.
Yeah, that's a very good point, Kristen. When I try to convince people to do research data management, it's usually, as I talked about, it's usually around reproducibility, that you want to do proper science, right? But you could guilt people and say it's your civic responsibility, right, to do this if you're getting taxpayer money. And we certainly could use, our taxpayer money being better spent. So Brock, what you got for us?
Yeah, so mine are going to overlap with most of others, and also some of this has some recency bias, the current challenges we're having. The three things I have are cost. How do we actually pay for all these different storage and data services? The second one is value, which is really about if the data we've already got, how do we know what it is, who else could use it, metadata about it to be able to, again, increase the value of data we've already got by making it reusable. And a lot of that falls into the FAIR principles. But the last one is risk, and that can be data loss compliance risk. You could risk a lot of different ways. The cost one is a big one that we're dealing with at our campus, primarily because of the way that we fund this activity. So that is currently front and center for us about how do we make sure low value data is not taking up space on high cost, tier one systems, versus, low cost archival systems and things like that. And also, how do we, because we generally are a recharge organization, we broke away from full recharge a number of years ago, which was great, in terms of encouraging adoption and appropriate behavior. But people are concerned about how much they're actually spending on these different things. And I stole this from somebody else a long time ago. I wish I could remember who it was, but there's two types of storage, new and full. And so that's the fight you're constantly having, and pretty much they're down to the moment. And truth is, in the Midwest, we have this thing we call a junk drawer that kind of holds everything, and that's kind of how people treat their storage. So nothing's organized, there's no metadata, and when it comes time to potentially free up space, you don't know if you've hit our internal university policy of 7-year data retention or not because you don't know what project it is, you don't know how anything's organized, you don't have a data dictionary, you have nothing. And if you want to go to like an institutional repository, like ours at Michigan is called Deep Blue Data, or a domain-specific repository, something like ICPSR or Biobank or something like that, you're effectively, it's like when you show up to your CPA at the end of the year with a shoebox full of receipts. I have no idea what any of this is anymore, but you figure it out. And of course, nobody's got time for that, and that's a very expensive way to do stuff. And so, anything we can do to like automate processes or a thought that I've really had recently, and I have to be a little bit careful here because we're currently in RFP that involves Starfish as a tender, which has a relationship with Cambridge. But one of the things here is like, look, can we make things useful during the active phase of a project where collecting and organizing data and collecting metadata and other things that would help people while things are active, that shoebox can come with a whole bunch of sticky notes on it already saying what the heck was what when that 7 years comes around, instead of trying to figure it out after the fact, after the students left, after the postdoc left, after everybody in the lab has turned over, because people are paranoid to delete anything. Nobody wants to delete anything, and we find a lot of that just because they don't know what is there, and they'd rather hold on to it than run the risk of deleting it and then needing it, even if that needing it is highly unlikely. I mean, just looking at the statistics, our tape archive is like 22 petabytes. By the way, we've only had the thing 5 years, so it went from 0 to 22 in 5 years. You should assume your data volume doubles every 4 years, or no, volume doubles every 2.5 years. But we've read back like less than 0.1% every week. Right? So it's right once read never. And so it's like, great, tape's great for this, especially for those of us who pay for our data center electricity and cooling, right?
Yeah. Okay.
So it's like nobody wants to use it, but unfortunately, it's the only thing we can afford. So again, unfortunately, I'm struggling with the how do we pay for bust out growth?
Yeah,
So
fantastic answer, Brock. And you kind of hit on one of the major problems we have with bare metal HPC research computing and POSIX storage is that our observability is just not great into what's
yeah,
happening on a file system.
yeah,
And we end up creating homegrown tools, right, to crawl
yeah.
file systems manually.
Can
And
I
if
share a picture that I've got here?
sure, go for it.
Okay. This is something I've been floating around for a while. People like talking about storage. Storage is bit buckets. Let's talk about unstructured data ecosystems. And this is a very research computing IT centric view. If you were a data archivist, like a librarian or a data scientist or something, you might have different ways you look at this. But too many times people just look at the NAS and the archive and your backup. And if you're an enterprise person, a SAN. And they completely ignore how do you access, transfer, share, automate data. They completely ignore how you search single pane of glass across all these different data sources, how you tag, how you automate workflows, and things like that. And we really should be thinking about ecosystem. And again, this is about raising the value of the data that we've got and making it easier to work with. And collaborative science is kind of the norm anymore. And so identity and everything else, comes into play. And a lot of us just use Globus and it solves a lot of these issues. But I think when we talk to leadership a lot of times, they see the bill for the Isilon, the VAST, the GPFS, the Luster, and they're like, whoa, what? And it's like, hey, 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 actually, we need all these other things too to take this thing we're going to have anyway and make, ease of use and increase the value and visibility and everything into the system. So this has been a thing I've been pushing for a long time, is this idea of an unstructured data ecosystem, staying out of structured data,
Mhm.
vector databases, relational databases and stuff. This is just dealing with the NAS and the files. But a lot of times people forget that you need a good identity system. You need a way to share data. You need a way to be able to move data across institutional boundaries. And you need auditing and you need all these other things to be able to make sure you're compliant with all these different requirements and stuff. So this is a pet peeve of mine because it was like, well, how much is the storage? It's like, no, 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 no. How much is the ecosystem? What is every value we can bring you to the ecosystem? It's like, well, my USB hard drive costs. Like, no, 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 no. Does your USB hard drive tell you where things are, tell you who wrote it, helps you share it with others, helps you collaborate? I don't think so. Right. So sorry, I'll
Yeah.
get off my soapbox
No,
now.
no, we all have our soapboxes, and I
Yeah,
appreciate the passion by which you talked about it.
yeah.
There's a really
Globus is
great,
the way.
yeah, Globus is, yeah.
Having everybody in the same ecosystem makes everything easier. Everybody in common in Globus and yay.
Well, I think, well, so you bring up an interesting point. One of the nice things about Globus is it uses your institutional credentials, but it lives outside of institutional IAM borders, right? Most science projects are multi-university, and most storage we have at the campus level are POSIX file systems behind a VPN, via SSH or SFTP, and you have to have an account on Active Directory. So, or LDAP. And so instead of doing that, scientists end up doing shadow IT type stuff. Or if they have a Globus infrastructure, use Globus. I also am going to put in a plug for S3 in general. I'm a huge fan of S3 storage. S3 is API key based authentication, right? For accessing it opposed to traditional username and passwords. And if you can hit the internet, you can hit S3 storage. And as a plug, if you want to play with S3, go to the accessci.org, request access to Open Storage Network. Any project can get up to 50 terabytes free. So come play with Open Storage Network. We also had a really good question in chat from Vanud is, how do you protect sensitive data from leaking? You can make your storage rock solid, but once a novice member of the group gets access, how do we ensure that they treat it with some diligence? And I think we need sort of a fundamental shift in how we think about security of data and how it intersects with research computing. We tend to build bottom-up security infrastructures where we take our bare metal HPC recipes and post-process NIST 800-171, but we end up getting policy-based data security, which is the moral equivalent of a EULA, which your users don't read. And as soon as they get access to the system, they egress it. What you need is mechanistic-based security and a top-down design. And I could go on this forever. So philosophically, if you're interested in this kind of approach, contact me offline. Of course, I have commercial solutions, but I'm also working on a project on the open source side to do something similar. So I'm going to ask Sesmita the question next. But first, Sean, I'm going to come to you first on question 3, and question 3's in chat. So you can start thinking about it while Sesmita answers her question. So Sasmita, it's yours.
Yeah, pretty much like how our role very much aligns with the way Brad has described. We deal with all kind of data, like the restricted data and user data, and we are also all that storage is behind the VPN. So most of the time, we spend like to educate these users, they are all our university users, like faculty, staff members, researchers, students, all of them, those who are part of the research group. And we try to provide as much training to them and how the different policies are implemented and how they can, what are the various storage available for them and what is the limit for each day for all this data storage. And they should always have a alternative, as the Chris has mentioned, like put your data in cloud, like S3 or wherever it is available. We try to encourage them, besides having their storage, local storage, like on the clusters, or like some other storage that we offer them, there is a limit, and there is some of there is a free storage available to each PIs or each researchers, and beyond that they can invest on those projects and get more access also. And we try to provide them data backup, the security, and as they say, the restricted data, that access and the leak that should not happen. So we try to take care of these things.
Fantastic. Thank you very much. So next up, why is research data management important? What are the reasons that CI facilitators should encourage researchers to put effort into it? So Sean, Floor is yours.
Okay, yeah. This sort of ties into what other folks have kind of said previously, but data is the new oil or the new gold, as it's been phrased, in relation to AI. So, and in order for data to be useful, it has to be processed, analyzed, all those sorts of things. As somebody mentioned, funders are wanting their investment, that the money to collect, create this data to not be wasted. So hence data management plans, all those sorts of things are significant for the researchers to continue to be able to do their research and get funded. Also, storage, as we've mentioned, is a finite resource. So looking at good practices and how we manage those things to make sure that we efficiently use the different types of data that we have, flash and NVMe versus tape, as has been discussed. So teaching researchers where the appropriate places for those things are. So that also helps with some of the cost that we've discussed. And then also, um, I think just I mentioned this, aiding researchers in future grant research collaborations. So the better their practices are for being able to, store their data, manage their data with metadata and FAIR, and being able to share and collaborate within national domain repositories and things like that, I think will lead to additional data papers, publications, the carrots that they're kind of looking for as faculty and researchers. So translating it into they put in this effort, they get these things at the end. So,
Fantastic. Kristen, why is research data management important?
Well, it's important for a couple of different reasons. The biggest one, I think, a misconception among a lot of people is that data storage, it's a privilege, not a right. And I think a lot of people just assume that the university or central resources are just going to give you a platform to store your data and it's going to be free. And somebody pays for it. That it's not always the PI, but it is definitely central resources. And sometimes it's a chargeback model and sometimes there is not. So at Northwestern, we have a chargeback model for our researchers who are part of Northwestern proper, but with our medical school, the medical school has decided to subsidize their researchers on our Isilon, which is great for those researchers, not great in a shared storage solution where once the FSM, the Feinberg researchers start to kind of encroach on the data caps, it kind of impacts the entire service. So it is kind of instilling in folks that it is a privilege. You do have to be a good steward of a shared resource. It's not just yours. You are sharing it, but then also making it a lot easier for folks to be a lot more nimble when you have to move from one storage solution to another one. So I think a couple of other institutions on this call, I'm sure, had to do a migration from Box over to like Microsoft products like OneDrive and SharePoint. And this was a huge lift, especially for our faculty, because they did use Box as their junk drawer and their storage drawer, and they baked that into their award proposal, saying that data storage was free, that they got it for free. And so, yes, in some cases, they were able to move into a similar storage solution in a Microsoft product that is quote unquote free for now, but we have to keep telling them, like, this too is a finite resource. You might have like X number of terabytes that you were allowed to have, but at some point Microsoft is going to cut us off and you will need to start managing your data again. So instilling in people that we have to be able to organize your junk drawer so that if it's time to move, you can pull out the junk drawer and put it somewhere new and not have to like sift through and try to figure out where the proverbial receipts are.
Yeah, definitely. I was talking about shadow IT and science projects, right? And how, they when projects are multi-university, if you don't have an easy solution, they go to things like Box or Google Drive, right? And last year Google reduced their free tier, and I know several organizations who found 2, 3, 4, 5 petabytes of data that they all of a sudden had to start paying for, and it cost them, upwards of $1 million over a year, just on the amount of time it took to egress the cloud via Globus to a properly supported campus solution. Yeah, so very good point. All right, Brock.
So I agree with everything. I would encourage you to be careful though about when you're talking to a faculty member, things like saving them time in maybe 5 to 10 years when they have to migrate between something.
No, totally understand.
They might be looking at chairs someplace else, right? So things that make our life easier or make their grad students' life easier pretty much don't resonate with them on average, even though we do tend to spend an awful lot of time talking about those sorts of topics. Again, I go back to that value thing. if you think about and organize data in like a project-centric way rather than a user-centric way, so that you can know what's what and you can understand what you have, you can then expose additional value from that might be of more immediate, because most grant work, builds on top of itself, right? It's rarely something completely in a vacuum and then light it on fire and you can go do the next one. That does happen. And it tends to happen as students kind of hand off things, right? I've seen code where like the same function was implemented 4 times because they had no documentation of what functions existed to implement common things and stuff like that. But leading them in a direction where we want them to be, but by showing them how this benefits them immediately or in the near term, um, will, whether you're telling us like, oh, this new AI tool will be able to ingest it better, and then you'll be able to use it as your little lab assistant, or, just something that encourages them to get them to where we want to be, do it with a lens of how does it benefit them sooner rather than a future maybe. And because you know we we've done these migrations and we basically get the you did this to me. Couldn't you just pay the bill? And it's like it's a big bill. It's a big bill. Our migration from drop or box to Dropbox and then Google happened immediately after that. As an institution, we have a lot of change fatigue just around what I consider desktop scale storage or consumer cloud or whatever you want to kind of call those tools versus like S3 for data center scale cloud or what we consider in the HPC world, data center scale on-prem. Um you got you gotta be careful, and we've struggled because there's too many of them and there's not enough of us to go around to kind of handhold every one of them.
So,
So like I liked what someone said at the very beginning about documentation and other things. That's one of the things we're starting to look at doing. I still doubt any brand new faculty member who's trying to figure out how parking works on this campus, let alone what the best recommended practices for organizing data is a thing. Um, One of the things that came up around public access to data and organizing data nicely, encouraging people to put them into open repositories that we have not made move on, but I thought would be really effective is actually making data collaboration, data publication part of the tenure and promotion process. Give it teeth. It's basically
yeah.
what it is. Give it teeth. That's the stick version versus what I was talking about earlier, which is the
Yeah, and
coming
we'll
up with
get
ways
into
to encourage
yeah,
them to do something because it benefits them. There's the
yeah.
kick.
The next question we get to, I'm going to phrase as carrot and stick, right? As options for making them do the right thing when we get there. But good point. Sasmita?
Yeah, this is really important for us in the sense, like, as you said, all of you agree that we offer to each students, I mean, each member of the university, at least they have access to OneDrive, Box Drive, with a cutoff, I mean, with a minimum at least 1 terabyte of storage data. And besides that, what the other like the problems, I mean, the bottlenecks or what are the we try to overcome. There are some of the PIs and all, they are like 30, more than at least 30-year-old data or more than that. In that case, we need to have a special research management, sorry, the data management guidance to them, provide storage, provide maintenance, and provide data access and protection, all kind of research data management kind of training, and all kind of special attention to such kind of data is also part of our task. So in those cases where I feel like our role is very important to handle this kind of data. And besides that, the day-to-day, like for being a HPC, like in the HPC system, like we encourage users, like where we have to see the performance and the speed and all this kind of when the users they run their job, but they take like they consider it's like a data storage where so much data, like if we don't implement the purge policies and all those things, it piles up to so much that it affects the EO or the input output performance over there. So there I find our role is very important to implement all this kind of to let them know about the data management and how to have control over it.
Yeah, thank you very much. And one thing I want to point out is cloud storage, your Box, your Dropbox, your Google Drive, et cetera, is not just for GUIs and Windows and Macs, right? You can leverage it from HPC systems. You guys are probably all familiar with rclone, right? Rclone is like rsync for cloud storage. And if you have modest data sizes and you want to implement a simple like check-in, check-out workflow with Scratch file systems, pulling down from Box or Google Drive via rclone, running your job and checking it back in works for a lot of workflows where data gravity really is not an issue. So we're going to have Brad answer this question in next. And then Kristen, you're going to be first up on question 4, which I just put in chat. So Brad?
Yeah, I think everybody's covered things pretty well. Just to add a few things and reiterate, research data management is important for data quality, to have confidence in your data, make sure everybody in the lab knows what the data is, where it's at, and to maintain that metadata. Just like the organizational aspect. One point, I don't know if anybody's mentioned, for everyone to know where their backups are and to make sure you can get the backups when you need them. There's certainly been cases, I thought we had a backup of that, and now we can't find it. So it's important for that continuity too. That was discussed, I think, in this morning's session too. There's so much turnover in labs, to be able to keep track of what's what.
All right. Thank you very much, panel. So question 4. How can CI facilitators convince researchers to put effort into research data management? What has worked well for you? So in the previous question, we talked about appealing to their good and why it matters and why you should do it. But let's talk more about carrot and stick. What have you tried to do that incentivized or de-incentivized, good versus, bad practices? So Kristen?
Yeah, my answer for this one is never let a good crisis go without like some sort of, benefit here.
Yeah,
So
I like that.
I know I kind of mentioned the whole transition from Box, but it is like it's these crises moments. And again, like faculty members have better things to do than manage their data. We know that. Ideally, they would designate a data manager in their lab who would be fully like responsible for onboarding, offboarding, setting up the file structure, tagging data, making sure that it's appropriately going through the data lifecycle into different storage solutions based on that lifecycle. But we know that that is not always the case. So yes, what has worked for us is having just-in-time conversations with faculty members when we have had to change storage solutions, but also when most recently our Isilon is coming up to we're hitting capacity, and so we were able to identify the top 23 or so top data consumers and have set up interviews with them. And we really thought that we were going to receive a lot of pushback from them saying, we don't need to talk to you. Like our storage is free. Like, don't bother us. Like, we don't need to worry about this right now. But a lot of the faculty members we've realized want to know what their data consumption is. So showing them exactly what they've consumed and the age of their data, the last time it was touched, was very eye-opening for them. And what we didn't realize going into it is we made assumptions that they didn't care, but really they wanted to be good stewards of the data storage solution. So they were willing to take a look through their data and trying to make some changes to it and identifying data that they maybe could either delete or archive. So Brock, we too are working through a Starfish project, and it's been.
I was just going to ask you what tool you were using. Okay, so it's Starfish as well.
Starfish also, and it's been again like very eye-opening for us, but also very beneficial for the faculty members. So what we're going to try to do, at least for the not just the top data consumers, is on our yearly billing cycle for the faculty members who do pay, we do kind of want to show them what their data consumption looks like and be able to provide them with some insight about what data they could maybe archive off into a different solution that would be less expensive for them, free up some storage for them on the active storage, but also try to help them think about how to manage their data better.
Yeah, and I'm going to go ahead, point out the most obvious stick, which is at some point you might just have to implement chargeback mechanisms, right? I've tried show back, what you're talking about right now, right? And in the past, I've tried shame back, where you create a list of like the top 10 offenders, And when I did that, I used to post it on the bulletin board in the CS department of one of my previous institutions. And after a while, they were competing to be at the top of the shame list. So that actually didn't work out the way I anticipated. But the reality is, irrespective of the current funding crisis and what's happening in DC now, funding from the NSF to research computing. Can you please mute yourself?
No, okay.
Please mute yourself. Thank you. Irrespective of the funding cuts now, since 2010, research computing funding has decreased dramatically, and even adjusted for inflation. And a rack of equipment in 2010 was $150,000. Now a single server for one person doing AI is $300,000, right? So and with the rate data's growing, at some point you might have to just bite the bullet and start charging people for storage, right? So all right, let's see here, Brock.
So I don't have great answers for this one, unfortunately. But what I will put out there, we are charged back. In fact, when we first launched in 2018, our first storage offering, our goal was to be 100% cost recovery, and we got zero adoption. So we still had the security issues and the data loss issues and everything else. So we're kind of somewhere in the middle. What we have is we have a model of we are still charged back. It excludes certain costs, specifically capital, but labor, software support, data center utilities, and stuff like that are still on the rate. So it's kind of like trying to split the difference with people. So they got skin in the game. But we also implemented a thing we called their U of M Research Computing Package. I can't take credit for this. We stole this from our medical school who used to fund using our services for their researchers. But we give everybody 10 terabytes to start. 10 terabytes is a small enough amount that you really don't have to bug anybody with it. In fact, we currently have approaching 3,000 volumes in our system, and 7% of the users use half the capacity. Ignore the 93% that use half. It's not worth their time or your time. That last couple, because we do charge them, they save money and we save money. So now it's worth the effort. What we have done is we haven't really formalized this. Our goal with this RFP is to finally formalize something. But in the meantime, I'll drop a link into chat if anybody wants like a more open source kind of version of something that we wrote. We wrote around a tool from Los Alamos National Laboratory called Goofy, which is actually meant for file system search, and made it so that you can basically find out, hey, here's the directories that have, 100% of the data hasn't been touched in 6 months. And just being able to show people what they have, because again, all they have is a folder name. They tend to be, whether it's leadership wanting to know who's using stuff, whether it's individual lab managers or PIs wanting to know what students consuming stuff or what's old, they just don't know. They've got a folder and a file name, and they've got nothing else to work with. So just giving them this kind of information really empowers people to be able to do stuff. The next thing so for these big users, because we do charge for it, they tend to latch on real quick because they're the ones who are dealing with the joke I said earlier, which is they're constantly butting up against full. Those who are the 20% that consume 80%, they often are constrained by how much data they can work with. And so more data they can identify to destroy or archive opens up opportunities for freeing dollars to do more things, right? Especially if you are in a chargeback thing. If you're not in a chargeback, I don't envy the position you're in, right? Because you're gonna have to have like stricter policies, right? If you can't govern by cost, you got to govern by wait time or allocation process or something like that. So they tend to be very happy when we can show them like, here's how you can discover old stale data. And the other thing is we wrote a tool that with one command, they can tar and send via Globus API to our archive with a single command on our system. So you can literally
archive tar on the same GitHub repo.
Yes, yes, yes.
Thank you for creating that tool. I use it all the time.
Oh, you do? Okay, yeah, okay. 'Cause it's trash code, but it works. But the point is make it easy. Because one of the things you will run into is the lots of little files make using archiving hard. And honestly, these graduate students who are doing most of the work, they've got a 4-year career, and half of them have never seen Linux or tar or command line before, and they're being thrown into the deep end, and they've got 4 years to get their PhD and get out, right? So the more we can make it easy for common workflows and stuff for things like archiving or identifying stale data or things like that helps. But yeah, I mean, basically again, by it was like, hey, here's all the stuff you could free up, and you could stop paying for that and redeploy those dollars. And again, in our setup, we do charge, but we're not full cost recovery. So the less storage they consume, the more money it saves me too, right? We both win. Um, uh, they tend to be pretty happy with that. But again, what we've actually found with these big data consumers, especially like geneticists and certain types of instruments, they'll immediately fill it back up because they're like, oh, cool, that freed up budget, and I'm just generating more data, filling it up sooner, working with larger data volumes and stuff like that. Unfortunately, I do worry in the long term. I don't have an answer for this. I do worry in the long term that this strategy of provide tooling to, if you could draw a line between active storage and archive storage, and you could move that line about when you can use it and try to have tooling to push up that line where people feel comfortable sending it to the archive because either restores are fast or it's easy or something like that. Data visibility, metadata visibility, whatever it is, so they can feel like they can trust the archive. I feel like that starts losing steam in a world where people are like constantly you know, training new AI models on all this patient data, and every 6 months they want to do it and they want to use all the historical data. And so it really is going to be an append forever, and the data is being actively used, say, every month or something like that, and just making that painful. That I don't have a good answer for. But luckily, so far, most of us are still supporting the traditional research life cycle of get new data, derive some understanding from it, retain it for potential errors, revisiting, or publication. Right. So that does work pretty well so far because I mean tape and Glacier are cheap, right?
Yeah, yeah. Write once, read never, right? And just give you an idea what cheap is. Glacier is $12 per terabyte year, right? Which is almost free, right? Dropbox is $99 per terabyte year. Wasabi is $60 per terabyte year. $12 is pretty good. All right, Sasmita, same question. What's worked to try to get researchers to adopt or buy into research data management?
This is also hard for me to answer. And I don't think we have any strict rule yet. But yeah, as Brad has, I mean, Brooke has brought up a lot of, general ideas or these are the things what we are also trying over here in our institution. But recently we have brought down, we have raised the price to bring down at least if they cross beyond 5 terabytes of storage or these things, then it will be chargeable or such kind of stuff. And as he talked about the tools, like we have also recently implemented a tool so that they can know their file status. But we don't know, like we still have to bug them or let them know, like this is you can go ahead and use the tool to know like what is the uses of your storage. But the other tool that you and Chris has mentioned, maybe I would like to implement that and I let them educate about how they can tar and archive their stuff uh, and upload it or save it like a second backup they can take or they can download it, those things. So this is really a hard question for us. We are still struggling, but these are some of the things what we have also tried and we're on our way.
Brad, any success stories?
Yeah, one concept that we've tried, and it sounds like kind of a simple concept, but it turns out to be pretty difficult, is creating roles for the labs and trying to get the labs to adopt them because PIs are busy. They don't sometimes want to be bothered with them. They have grad students that are closer to the data and closer to working on the cluster. Uh, and also the labs often have managers or admins, but we don't know about them.
Mm-hmm.
So if some lab member comes and says, "Oh, this person is gone, can we delete their data?" No, we can't give them the authority to do that. But the PI can assign these proxies, and we use ColdFront
Mm-hmm.
to for labs to track their allocations, they request storage. So we've made some customizations in ColdFront to allow PIs to assign proxies. So we have account access, they can assign a lab member to approve new accounts. They can assign a storage manager who can request the new storage because we do chargeback. So they're allowed to spend the money. Not just anybody in the lab can do that, but the PI can appoint someone. And also data admins then who oftentimes will use ACLs for people who are listed as data admins, set the ACLs across the lab data shares so that they have access to everything and are allowed to do that management.
Yeah, that's just exactly what I was just about to ask you. If you think standard Unix POSIX groups are enough, or do you need like ACL support in order to do this properly? And I suspect it's the latter, right?
Right. Okay. Yeah, we found that was a lot easier than setting up special groups. We've tried that in some cases as well, in order to restrict who has access. The ACLs work much better than having a ton of groups in AD.
Yeah, you can you can do ACLs with infinite number of groups, right? Where you end up having a group for every linear combination of two people, right?
The problem with that is actually setting those things on 50 terabyte, 100 terabyte shares. Yeah. It takes a week to go through all the files.
Okay. So I'm going to go to Sean in just a bit to answer that question. Brock, you're going to be first up in the next question, and the question is in chat. So Sean, carrot stick, any success stories or how you approach it?
We often share the story of one of the research projects that we were on where we had provided storage, and one of the research teams, their graduate students decided not to use it and their laptop died, and so they lost all of their work. And so we like to highlight for folks on the sort of stick side of things, where it's not really us welding the stick, but they're putting the stick inside their own bicycle spokes as they're riding their research work down the road.
There's two types of research projects, right? Those who've lost data and those who haven't lost data yet, right?
That's right. They only do that once, really. And then on the carrot side, I think I've mentioned this before. There's journals now that have data papers, and so letting folks know about those things that they can actually publish on just the data set itself if they've done all of the nice end-to-end management and metadata on those sorts of things. And also a number of publications are also requiring links or to some of the data in remote data repositories. And so they end up having to do some of that stuff. So trying to give the carrot for what those things that the outputs that they're trying to get to for their awards, their grant, their faculty tenure. So highlighting the opportunities there.
Okay. So I have two carrots I'm going to talk about that are related. So the first angle I bring it is in terms of reproducible science, right? AI, ML, and training models is something that worries me. It keeps me up at night around reproducible science. We've all supported HPC systems, and I'm a traditional simulation guy by training. I'm a computational quantum chemist by training. And when I was doing research computing support, you have people all the time submit a ticket and say, my workflow no longer works, right? You go in and look at their LAMPS input file, and you see at the bottom a :WQ, right? Where they opened it up in Vim, they tried to exit the editor, they left a little turd in the file, and now this fixed format file no longer works. Well, what do you think about training a model that's just based on data, that has no physics, and now you're doing decision making with it? But the data you trained it on lives on your POSIX file system, and you assume no one touches it, right? That makes me anxious. And so, I've sort of done a lot of work on bringing the tools from the cloud native space to bare metal HPC to do reproducible computing. And I also use that angle as a way to get money to do science in terms of workforce development. As educators, we do research, but at the end of the day, one of the reasons the National Science Foundation funds us is to create the workforce, right? The next generation of scientists who are going to power our economy. And the vast majority of the commercial space doesn't do bare metal HPC, right? We've been doing batch computing the same way since I started my PhD in '97, and we still do it the same way today. But in the commercial space, most people use Kubernetes, right? There are very few companies who are using batch HPC. Of course, Shell does, oil companies do. Boeing uses batch HPC, and one could argue they should possibly use more as part of their design phases before building stuff. But the Googles, the Metas, the Facebooks, they're using more contained native infrastructures. So what I tell researchers is bring the concepts of GitOps, data ops, ML ops into your research. Here are some tools to do them on bare metal HPC for data provenance, governance, control, history, reproducibility. Furthermore, you can use this as an angle to get money around workforce development. And that's sort of the carrot approach I've used to get research data management adoption, especially in data intensive science workloads. All right, question number 5. What are the best techniques for helping researchers learn effective approaches to research data management? Brock?
I don't have a good answer for this one in terms of like the general case and something that will scale. Like I said earlier, we're just starting to talk about creating some documentation in partnership with our Office of Research about best practices, about organizing data, where to find data sources and stuff like that. So I really don't have anything that scales because otherwise it's kind of been these one-off cases when they fill up something, their workflow stops, the funding ends, something forces them to face the picture of what they're consuming. And again, like this is pretty much dominated by the small number of super consumers, right? So sorry, I don't have anything better.
All right. Sasmita?
Yeah, for us, what has really worked for us is one-on-one consultations. Emails never works. And orientation or getting feedback from them after the orientation or the training. But finally, we have started doing this one-on-one consultation and be a part of their team now. So besides our day-to-day activities, we are now part of these. We have identified like those who are the big users of data storage in this, about their work. And and maybe they have accumulated so much data, which is if it is more than 30 years old or something like that, we have become a part of their team now, so that they can at least follow us and how we implement these things to take regular backup. And for that also, we have started getting some student interns help, and we have seen that it has started working really. There is some improvement in that, and yeah.
Okay, fantastic. Brad, any insight?
Yeah, something coming up for us is kind of a combination of training and infrastructure. So we're working on consolidating some of our storage. Right now, we have things spread out from Lustre, Isilon, Vast is newer, some NFS stuff, and tape. And we're all friends here. I can admit some labs still have their own boxes. But we want to consolidate that to maybe 2 or 3 or maybe 2 technologies, and then the training and a change in mindset from that to have labs think more about what's your hot storage, what do you want close to the compute, probably doesn't have backups, but it's going to be cheap. Everybody needs a cheaper option now. So you think about your hot data, your warm data that you still need locally, you still need access to, and then the cold data that can go to tape. So we want to use that consolidation to change their mindset a little bit and how they manage their data.
All right. Sean?
Okay. A lot of the researchers that we work with also want to leverage some of our computing structure related to their data. And so we require onboardings for everybody who gets access to that so that they understand all the different data storage tiers and what happens to them. And someone wrote in here about Scratch and the student losing their thesis and things like that. So we're pretty upfront about what happens to that space, as well as having automated emails and things in our system to help encourage good behavior before things get bad in some of that aspect. We also do additional weekly workshops and trainings related different aspects of research within cyber infrastructure, and data management and storage and things are in there. And so we provide those at least every year or every semester, along with recordings and additional materials that people can access offline to help educate them and show them some of those things. Additionally, we also work with some groups with things like science gateways or portals that have integrations in them to help automate some aspects of data storage. So if they're leveraging some of, at least on the compute side, you can link the inputs from the data, the parameters, the software that they're using, and the outputs kind of bundled together through this sort of system that automates some of those aspects for them. So we've seen some help in that, helping researchers a little bit.
In chat, I put a link to a tool called HPC Workspace, and it sort of solves the Scratch file system problem in that you don't have to homegrown a solution yourself. Instead of deploying a Scratch username for everyone, you just deploy a top level Scratch, and then users use the HPC Workspace tool to deploy project specific Scratch spaces. You as an administrator can define heuristics on how long that storage is available based upon the amount of capacity they reach. There's many different knobs. It'll automatically, clean up, expire, notify users when it's going to be deleted. It has a trash can mechanism where it first moves the Scratch space to a dot directory, which is hidden from the user. So when they panic and say, my dissertation was deleted, you can say, give me $1,000, here's your dissertation back, or you can just give it to them for free. And it's a really nice tool that can also, if your file system supports ACLs, your users can create Scratch file systems and share them with each other without you getting involved. Really robust tool that's been in development for about 15 years. So just as an aside. So Kristen, you're going to answer that question in just a little bit, but I want to tee up Sasmita, because for the last two questions, we're going to combine them into one, where I want you to tell me about one dumb mistake you made and one smart thing you did around research data management. So Kristen.
All right, as far as best techniques, I think we're fortunate that we have data management specialists and librarians in our Northwestern library as well as in our medical school. So we partner pretty closely with them. We share a lot of expertise, experience, but also share consults. And kind of going back to what Sasmita said, we do find that the consultation is really the best way to educate. And normally PIs or researchers are not coming to us saying, hey, my data is a hot mess, like, please come help me, because it's a problem and it's work for them. And usually when you have to solve a problem like that, really you're giving your future self a gift. And you just want to spend the time like doing something cool, like not doing this kind of backlog of work. So usually we'll come in and do a consult about like workflow optimization, and we'll realize that, yeah, your data could probably use a little bit of help. You could probably streamline how you've organized it to help improve your workflow. And in one particular recent example, we were having an interview with a PI in our medical school, again, one of these top data consumers. And we realized that were consuming a lot of data because our high performance computing system doesn't do backups of the analysis that they were doing. So instead of trying to come up with like a better workflow, they decided to back up all of their data onto our Isilon. So now they've like really kind of like bloated their data storage when they didn't need to. So it was an opportunity for us to come in and say, hey, like this is a better way to manage your data and your workflow so that they could organize their data better and make sure that their active data was where it needed to be and their process data was where it needed to be. And they could figure out how to move the data back and forth based on where they were in the research life cycle.
Okay. So I'm going to give you two examples of things I did to help researchers adopt it. I kind of took a bookend approach. So when I was ran research computing at UT Dallas, I was also faculty there. And I taught a graduate class called Practical Research Computing. And it was project-based learning where I taught them things from architecture to Unix to Bash to compilers to MPI stacks to profiling, debugging, optimization, workflows, pipeline, and research data management, all in a couple of weeks. And it's BYOC, bring your own code, that you bring your research group's code and sort of develop the practices over the course, and you bring them into your researcher workflow. For those who didn't have their own code, I would allow other scientists who didn't have students in the class donate their software for their research group to the class. And over doing this at both UT Austin for about a decade and UT Dallas, I saw amazing returns on that investment by teaching the students and training them. The other way is a more top-down approach. So again, when I was at UT Dallas, I had a CC Star cyber program called Trekkies, named after the derogatory term for a Star Trek nerd. And Sasmita was actually one of my postdocs there, and we had a couple other postdocs as part of that workforce development effort. And I used an embedded model. And what I realized is, to borrow a phrase from Hillary, it takes a village to raise a computational scientist. And by that, what I mean is when I started my PhD in 97, I learned research computing from my PI, right, from my professor who wrote the software that we were using. And he was an expert in chemistry, not a great programmer. No, I'm just kidding. He was very good at programming, but I learned from him. But these days, everyone is doing computing, and a lot of times the PIs are no longer experts. So what I did is my postdoctoral program, I had multiple postdocs who were my postdocs, and I taught them sort of how I see the world and reproducible computing and data ops and GitOps and things like that. And then I embedded them in research groups. And they actually worked with that code and that group, and they were another scientist along with that group. So they would take my good practices and propagate them. And using that methodology, we really saw very good adoption of good data hygiene practices. All right. So Sasmita, we have the last question for you. First, in the spirit of helping our audience learn from our mistakes so that they can make exciting new mistakes instead of the same old mistakes, what's one of the dumbest mistakes you made in helping a researcher with their research data management? And then the flip side of that, what's one of the smartest things you did when you were helping a researcher with their RDM?
Yeah, the smartest thing I'll go first, like as you mentioned at the beginning, using the tool Arclone. So we did take some of those PIs and researchers, and they are gradually growing. What I got to learn from Chris, thanks to you, that is taking the advantage of the what is it called, OSN, right, Chris?
Yeah, open storage network. Yep.
Okay, open storage network. So that I got to know, got to learn through Chris when he was there at Massachusetts Amherst, and that lot of our PIs got good advantage through open source network, and we recommended them to use the Arclone and upload their data. And if they have a project for 5 to 6 years, some of our PIs they have 6 to 10 years of project, and they are nicely taking advantage of this resource to take backup of their data or do the data management, and they're collaborating with all over the US and all over the world, and they can easily access their data and carrying out their research work. And the dumbest mistake, what I can say, like as we have started this became strict about the research, the purge policies, like they cannot use the Scratch as their data storage. Rather, it should be for their EO work. But so being strict about that, recently I came across a PI and my old colleague as well that. He happened to go to a place where he has no access to SSH or transfer the data from his account. So I had to do the dumbest mistake, touch the data and avoid the purge policy. So that's what I will.
Oh, well, it happens.
Forgive me, Chris.
Yeah. All right, Brad.
I'll try to be quick. I'll say a good thing. I'm glad a lot of you mentioned data migrations, because we're just wrapping up a project that's taken about 2 years to move data off of some old Ceph VMs that we'd set up. Nothing against Ceph, but it's not sustainable for us. So we're moving them to other storage. And that's allowed us to reach out to the labs and tell them their options so that they understand where their data is going to be moving to, and also gives them a chance to consolidate that data and do cleaning, because now they're going to be paying for new storage. So that they try to reduce that as much as possible. It also gives them, the understanding of their storage locations and the technologies. Things like now they realize the slash data slash lab that they access is just a link to somewhere. So I think it's good for the researchers to understand uh, more details about where their data lives. And
All right.
I'll save the bad one maybe for stories from the trenches on Friday.
All right, Sean.
Uh, Telling them to use Google Drive. That was probably the unwisest thing that we did for a number of years when we had to do the migration. Although I mentioned it, we only had a petabyte to downsize in the end, so it wasn't horribly bad. Um, I think one of the smartest things that we've done, I think, is adopting some of the different tools that folks are mentioning here. So Globus, rclone, those sorts of things, and having documentation for those for our researchers to be able to uh, transfer their data around a lot faster. And with some of the latency and network connectivity issues that happens sometimes, those tools that resume large data transfers with a fire and forget is super helpful for researchers because it can be
Okay.
very frustrating if their laptop closes or there's a power blip or something like that to have to start transfers all over from the beginning.
Yes, definitely. Kristen.
So I'm gonna put smart and dumb in kind of the same kind of category and tie back to something that Jason Sims said earlier today during the reducing barriers to entry panel discussion. And it's about like trying to find that fine line between consulting and providing guidance versus doing. So in my team, we are definitely a bunch of doers. We want to be helpful, and by being helpful, what we want to do. And our leadership always tell us don't spend too much time with one researcher because we can't do that for everybody. But being able to recognize where, okay, this researcher has a problem. I know that it's not unique. It might be the first time that we're hearing about it, but I know it's not unique. And investing that time to solve that researcher's problem, knowing that we are going to build a resilient solution for the next researcher who comes with it. So in one particular example, we had a core come to us. They actually wanted to implement good data management practices, and they were using SharePoint with their to store their data. And so they came to us saying, we want to be able to identify data in SharePoint that has not been touched in a certain amount of time. We want to build in some workflow, and we want to be able to delete it once we've all decided that, yes, this is something that we want to do. So we had a member of our team who's actually on the call right now. Hi, Kevin, who implemented a Power Automate workflow that we had no prior history or skill set in implementing, but we spent some time learning the tool and we were able to implement this particular thing for this core. And we have been able to kind of tie back to it in some of the workshops that we've been doing. In another case, we do use Globus, but there are times where researchers can't use Globus for one reason or another, and then we need to offer some sort of SFTP solution. So we had wanted to stand up kind of a side service and market it as such using a VM and having faculty members be able to use it. And our leadership said, no, there's not a lot of use cases for it. It's like, but we know that there is. We know that we have not heard them, but we know it's coming. So even though we had to help one researcher, we made sure that when we stood up the SFTP for that particular researcher, that we documented it. And we knew that the next time that somebody came to us with a similar request, we would have it all ready to go for them.
All right. And Brock.
Okay, worst things. I've dropped a disk controller. I'm trying to re-rack it into data center behind me here. Um, Learned a lot of things as a student, like don't put 5 million files into a single directory, so all that kind of fun stuff. Probably the worst thing that we ever did was try to be full cost recovery build out monthly. Basically the OpEx model that cloud uses, given that's not the way faculty actually get funding. They get airdrops of money and then they're expected to retain and maintain stuff. So it didn't matter what our cost was, what our service capability was, if there wasn't a match of how they get money. And we've not fully addressed that. We still have challenges around that because we do still charge and we do still charge monthly. But we've addressed, the full cost recovery aspect to try to make it not so economically unviable. And these base amounts of offering covers, the majority of people so they don't have to worry about costs. And then a number of our academic units that I'm grateful to, the liberal arts school and the medical school have stood up and actually match the free base that the CIO provides to every researcher, so researchers in those departments can actually get more storage for free funded by their department. Um, but other than that, I mean, probably the best thing we ever did was actually originally deploying Globus. It seems like a lot of times either supply creates demand, that is, as soon as you solve how do you reliably move around large volumes of data, I dropped into the chat, the problem with big data is that it's big, the retry, the uh, longer something takes, the more likely something's going to hiccup somewhere and having to restart from scratch. And we have a researcher who uses it in the Arctic where they have unreliable satellite coverage and, it's constantly dropping in and out. And they used to just upload using box using their website, and if it would drop out, they'd have to start all over because they have no idea where the transfer is, and Globus kind of solved all that. So kind of having this Swiss Army knife of how do you move stuff around, how do you work around having to open up firewall rules, how do you work around having to teach people to use screen and a bunch of other things. Um, the identity matching across schools, the sharing, when they came out with Globus High Assurance for our HIPAA environment, really just solved a lot of issues for us. So that's really what I would say is that it seems like everybody has it now, but man, when we first did that, it was like right on the cusp of all of a sudden, it's like, where all this data come from, right? Um, and it feels like that happens quite often. That's why I say sometimes I wonder if we make things easier and we make things faster and stuff, people are like, oh, well, I'll use that now. And it was always there and we just didn't know, right? So.
Okay. And so for my failure, I'm gonna take something that Kristen was said about sort of chasing a researcher and trying to make them happy. So when I ran research computing, I had my number one sort of philosophy was never to be the victim of my own success. And what I mean by that is a lot of tools, especially in the cloud native AI ML and data management space, use a kind of like a drug dealer model, right? Where the first hit is free, right? Or it's $5 per user per month for teams of 5, but then a teams of 100 or $100 per month per user, right? And I was always worried about deploying a proprietary solution that became too successful, and then I could no longer afford it, right? So I built almost everything I did around Libre and Gratis, right? Open source tools. So I was working on this project with a faculty member who had sensors in the field that were collecting data, and they wanted to stream it back to a dashboard and able to do real-time AI ML and metrics and things like that. And, they were already using IoT devices in the field. So we decided to use MQTT as the data stream. So instead of using like AWS's hosted IoT as a service, I set up a chirp stack and VMs at AWS for the ingress of the data. And then the MQTT streams went to a Proxmox cluster in UT Dallas's data center. It got ingressed into an Influx DB and then presented with a Grafana dashboard. And when it worked really well. But when it went down, it was a little delicate and hard to replace. And when I left UT Dallas, no one knew how to maintain it anymore. And so by architecting something that I didn't want to be the victim of my own success, UT Dallas in a certain way and that researcher's workflows were impacted by my success. And I used to focus on what can I do versus what I should do. And one thing I've learned, especially in the storage space, Libre is not always gratis. That is, if it's open source, you can run it for free, but it's going to require a couple of FTEs sometimes to run it for you. And the storage space is really where the open source ecosystem falls behind. And one thing that it did was great. Well, instead of doing it on MQTT and Chirp Stack, we just started using rclone from the devices to an S3 bucket. And it just started working much better. And they also use OSN now. So I believe that is the end of our time in our panel. Thank you, everyone, for your time and attention, your great questions and great discussion in chat. And Henry, I hereby hand it back over to you.
All right. Let's thank our panel with a round of virtual applause. You know, you all of our panels, all of our speakers have been knocking it out of the park. I'm just so delighted. And I'm very grateful to all of you for a terrific panel. Thank you so much. And quick program note for tomorrow. So we're starting at 9 Central, 10 Eastern, 8 Mountain, 7 Pacific, etc. As usual. Uh, our first session will be explaining complex technical topics to researchers. That's followed by Beyond the Intake Interview, building lasting collaborations with researchers. Then facilitating cloud computing and explaining cloud pros and cons. And finally, tomorrow, assessing and anticipating researcher needs. So we look forward to seeing all of you there. And thank you, everyone. Let's all have a great evening and then be back bright eyed and bushy tailed at the top of the day. Thank you, everyone.